This is topic number 3 of the Algebraic Connections Study Guide. We are going to use geometric properties of quadrilaterals to establish relationships. Those relationships are linked in the notes and this Venn diagram of quadrilaterals that shows you what you would need to actually prove in order to demonstrate that the shape is a parallelogram, a square, or whatever. When you get to the first problem, if you double click on that image, you can actually move the points around and even draw in the side lengths of that quadrilateral if you want. The question is, what kind of quadrilateral is this? Is it a parallelogram that kind of looks like a rectangle? We're going to get into it. So this is largely going to come down to calculating the slope and the length of each one of these 4 sides. To prove that something is a parallelogram, you're going to have to show that you have 2 sets of opposite sides that are both parallel and congruent. To prove that it's a rectangle, you're going to have to get a 90-degree angle going in there. So how do you prove that something's a right angle? Slopes again. If you can show that the slopes of the adjacent sides have opposite reciprocal slopes, then you'd verify that that would be a 90-degree angle. So we're just going to go around and each side, and I'm going to calculate the slope and the length of each side length. All right? So segment AB looks like the slope, to go from A to B, it looks like I'm going up 3 and over 1, so that's got a slope of 3. The fun part about doing the length, since you just did the slope, rise over run, you can just take that same rise and run, just slap it into the Pythagorean theorem, you come up with 3 squared and 1 squared, which is the square root of 10. That's the length. When I go to get side length, the side BC, slope, it looks like I'm going down 3 and over 7. And if you do 3 squared and 7 squared, together that adds up to the square root of 58. So now we've got 2 side lengths. It's clearly not a square. I wasn't expecting it to be a square though. But you also have a bonus feature of, check out these slopes. Are they opposite reciprocals? It kind of looks like it's a rectangle, but look at those opposite reciprocals those slopes are not opposite reciprocals. In fact, if you do the opposite reciprocal of negative 3 over 7, that's 7 over 3, and it gives you 2.3. That's not the same thing as 3. So that's not a right angle, guys. This is not a rectangle. That's important. It looks like maybe the only thing we'll be able to prove is that it is a parallelogram only. If you check the slope and the side length for side CD, I get a slope of 3 and a length of square root of 10. And so we definitely have one set of lines that are parallel. We've at least proved now at this point that it's a trapezoid. But maybe the other set of lines will also be parallel. We can look at the slope and length of that last segment, AD. Looks like I'm going down 3 and over 7, so that's negative 3/7. The length, I just did 3 squared and 7 squared a minute ago. Got the square root of 58. The slopes are the same. So this is a parallelogram. Why is it a parallelogram? Because we have both sets of opposite sides being parallel. Specifically, to throw some numbers in there, both segment AB and CD, they both have a slope of 3. If you look at the other set of parallel sides, which is BC and AD, they both have a slope of negative 3 over 7. So both sets of opposite sides are parallel. That's what makes it a parallelogram. It's important that you realize that we do not have a 90-degree angle, so we do not get to call this a square. Sorry, a rectangle. All right, moving right along to the second problem. I graphed those 4 points, and we have something that kind of looks like maybe it looks like a rhombus to me. Kind of looks like a parallelogram at least. So let's get into it. Let's get the slope and the length going all the way around the figure and talk about what we see. It might be worth noting that in that first problem, the lengths didn't really come into play, but I think if we're going to try and show that this thing is a rhombus, we will definitely need some side length comparisons. So let's talk about the slope of that vertical line. I think in Algebra 1 you call that undefined, basically because it's infinitely steep. So yeah, it's kind of weird to talk about how 2 undefined things are the same, but whatever. That just means that we have 2 vertical lines. They're certainly parallel. When you look at the length, because they're vertical, you can just look at the difference in the y values, and both sets are 5. So, good, we have parallel and congruent, one set of parallel and congruent sides. Let's check the other two to see if they're also parallel and congruent. Let's see, the slope, it looks like from k to l is down 3/4. If you Pythagorean theorem those numbers, you get the square root of 25. Let's go to j and m. Let's see, slope of negative 3/4 and length of square root of 25 again. All right, so we definitely have two sets of opposite sides that are parallel, but it's not just a parallelogram. Guess what else? All 4 sides have a side length of 5. All 4 side lengths are congruent, so that means that this is indeed a rhombus.